So let's look at basically how the three-phase winding that is connected to the stator of the motor is going to produce a three-phase magnetic field. So rotating magnetic field. Now for the induction motor, the three-phase windings are connected to the stator as it is shown over here. So this is the stator part, and then you can see phase A, phase B, and phase C. So as you can see, current is coming in over here and then going out, and then the current is coming in and stuff like that. So how these three phases produce what we call a three-phase magnetic field. Let's look at this. So as you can see, we have three phases which are separated from 120 degrees as we discussed in the three-phase chapter. All these three phases, at any point, of course, sum of the total current is going to be 0. Now observe when you connect these three phases and the current is flowing as it is showing in this diagram. At point 1, this is the zoomed in version of point 1. Observe that these three phases will produce a magnetic field which will be going from bottom to top, that is in the positive k direction. And this is the cumulative magnetic field due to the current flowing in all three phases at point 1 right here. Now at point 2, at this point, when your IC is -10 and both IB and IA are +5, of course sum of these three currents will be 0. At this point, observe that the cumulative magnetic field direction is changed. At point 3, same thing is gonna happen. The cumulative magnetic field direction is changed. So observe that the cumulative magnetic field is moving as the waveform, each waveform is moving. The cumulative magnetic field is also moving in a clockwise direction. And likewise 0.456, 0.456, it is going to move, and at 0.7, which is the same as 0.1, so one complete cycle, it is gonna go back to this point. So when each cycle of input voltage of the three phases is complete, we have one complete rotation of the magnetic field which is produced, cumulative magnetic field which is produced by the three phase voltages. And this is a very interesting and very important phenomena in order to operate induction motors. So what do we have here? We established that when we have a three-phase motor, three-phase stator, for each cycle of voltage, moving cycle of voltage, we have a moving magnetic field. That is a magnetic field which is moving with some sort of velocity in the clockwise direction. So that's what we established. So the speed with which this magnetic field or flux is rotating is called synchronous speed. Synchronous speed. And this synchronous speed, it depends on the input voltage frequency, the three-phase input voltage frequency, and how many poles per phase do you have. Poles per phase. For example, here we have 2 poles per phase, or a pair of poles per phase. And we can calculate the synchronous frequency using this formula. Ns is equal to 120 F over P, and it's in RPM. Right? So we have 2 poles per phase in the diagram above. And if you have input frequency of 60 hertz, then when you put 60 hertz and 2 poles per phase, then it's going to give you 3600 rpm or 60 hertz. So which shows you that a one complete rotation with 2 poles per phase and with the 60 hertz input frequency is going to produce a synchronous frequency which will also be 60 hertz. Now if you want to increase the number of poles per phase, you can do that. This is from your textbook. As you can see, they have made groups of poles per phase. So you have 4 poles per phase here, 1 2 3 4 for each phase, and then we have 8 poles per phase here. So the number of poles per phase, of course, is going to change the synchronous frequency. In most of our study, I think we are doing 2 poles but in some of the problems we are also going to do more poles per phase. But again, your job is to calculate the synchronous frequency that you will use in solving other quantities. Now, how are you going to change the direction of the rotating magnetic field? It is very easy. You just have to change the sequence of the 3-phase connections to the stator. So for example, if sequence is A, B and C, then you change the sequence to A, C and B, and it is going to change the direction of the motor rotation, direction of the synchronous speed or flux from clockwise direction, as we saw earlier, to the counterclockwise direction. So next video we're going to look at how the squirrel cage 3-phase motor works.